Assalamualaikum everyone and a very good day to all. In this video, we shall learn about time division multiplexing or TDM, which is one of the basic techniques of multiplexing. Here is the table of contents for you to navigate through this video. This video is the continuation from TDM video part 3. In this video, we shall learn about statistical TDM. As we saw in the previous video in synchronous TDM, each input has a reserved slot in the output frame. This can be inefficient if some input lines have no data to send. An alternative to synchronous TDM is statistical TDM. In statistical TDM, slots are dynamically allocated to improve bandwidth efficiency. Only when an input line has a slot's worth of data to send is it given a slot in the output frame. This figure shows examples of synchronous and statistical TDM. In the synchronous TDM, some slots are empty because the corresponding line does not have data to send. In statistical TDM, however, no slot is left empty as long as there is data to be sent by any input line. This figure also shows a major difference between slots in synchronous and statistical TDM. An output slot in synchronous TDM is totally occupied by data, whereas in statistical TDM, a slot needs to carry data as well as the address of the destination. In statistical multiplexing, the number of slots for data in each frame is less than the number of input lines. For example, here you have 5 input lines, but the slots for data, there is only 3 in each frame. The multiplexer will check each input line in round-robin manner, where it allocates a slot for an input line if the line has data to send. Otherwise, it skips the line and checks the next line. In synchronous TDM, there is no need for addressing. Synchronization and pre-assigned relationship between the inputs and the outputs serve as an address. If the multiplexer and the multiplexer are synchronized, this is guaranteed. It will reach to the destination of the output. No addresses needed. However, in statistical multiplexing, there is no fixed relationship between the inputs and the outputs because there are no pre-assigned or reserved slots. That's why we need to include the address of the receiver inside each slot to show where it is to be delivered. The addressing in its simplest form can be n bits to define n different output lines with n equals to log 2 of n. For example, for 8 different output lines, we need 3-bit address. Since a slot carries both data and an address in statistical TDM, the ratio of the data size to address size must be reasonable to make transmission efficient. For example, it will be inefficient to send 1 bit per slot as data when the address is 3 bits. It's just inefficient in its own way. This would mean an overhead of 300%. In statistical TDM, a block of data is usually many bytes, while the address is just a few bytes. For no synchronization bit, because there is another difference between synchronous and statistical TDM, but this time it is at the frame level. The frames in statistical TDM do not need to be synchronized. Okay, so that's why we do not need synchronization bits. In terms of the bandwidth, in statistical TDM, the capacity of the link is normally less than the sum of the capacities of each channel. The designers of statistical TDM define the capacity of the link based on the statistics of the load for each channel. If on average only 8x% of the input slots are filled, then the capacity of the links will reflect this. Of course, during peak times, some slots may need to wait. Before I end this video, please let me know how is your understanding on this topic throughout this video so far at this link. Your participation is highly appreciated. If you have any questions or comments, please let me know. Thank you and see you on the next video.